Hello everyone. In this session, I will further explain on the common discrete signal. The first common discrete signal is the unit impulse. Okay, this is the unit impulse in which delta n is referred to the amplitude is 1 at the origin. Okay, the others the value are 0. Okay, now let's look at the 4 delta n. What is meant by 4 delta n if compared to delta n? 4 delta n means that the amplitude is 4, okay, and still remain at origin, where n equal to 0. Okay, next we look at the 4 delta n plus 1. So n plus 1, we call it as a shifting. Okay, n plus 1 equals 0, n equal to minus 1. So the location at n equal to minus 1. The amplitude is still remain to 4. Okay, then what is the difference if you have 4 delta n minus 1? Okay, again, this is a shifting. Okay, it's a shifting. N minus 1 equal to 0, n equal to 1. So the position n is equal to 1. Okay, x-axis is the position n, is the n. So n minus 1, so n is equal to 1 and the amplitude is 4. Okay, now we look at another one. If you have the minus 4 delta n, where is the location? Okay, minus 4, as you know, this 4 is the amplitude, okay, at the y-axis. So if the minus 4, that means that it goes to the negative. So negative 4 is the amplitude. So your negative 4 at the y-axis. The second common discrete signals is the unit step. Okay, unit step is called UN. You will write in the way of UN. UN means that it has the value, okay, from 0 to infinity. This is the infinity, from 0 to infinity. The amplitude is 1 because 1 UN. Normally, we write it as UN. So the value is from 0 to infinity. If you have 3 UN, this means that the amplitude is 3. Okay, also from 0 to infinity. What if you have 3 UN minus 3? N minus 3, the minus here is referred to the delay version. So n minus 3, the location is n equal to 3. So starting from n equal to 3 to infinity, the amplitude is 3. Okay, what if you have 2 UN plus 4? Okay, amplitude is 2 and the n starting from minus 4. Yes, n plus 4 equal to 0, so n equal to minus 4. So from minus 4 to infinity, you have the amplitude of 2. The third common discrete signal is the unit ramp. Okay, unit ramp is like a triangle. It's not a triangle. Yeah, it's more or less like a triangle. It goes up. Unit ramp we write as Rn. Okay, if Rn, normally unit ramp is starting from 0. Okay, 0, 1, 2, 3, 4, 5, 6 up to infinity. And if Rn amplitude is 1, so it's starting from this means that each step is only 1. The difference is 1. So 0, 1, 2, 3, 4. Let's say if you have 2 Rn, okay, this means it's still starting from 0. Okay, this 0 must count, okay? You shouldn't start at, if you start at 2, okay, if you have 2 Rn, this means that each one is the amplitude is 2. So 2, 4, 6, 8. If you have 3 Rn, is 3, 0, 3, 6, 9. Okay, so this one is the amplitude. And starting at the origin. If you have the 2 Rn plus 2, This means that it's starting from n equal to -2 and the amplitude is 2. For each increment is 2. So starting from -2, you have starting with 0. So 0, 2, 6, 8, 0, 2, 4, 6, 8 up to infinity. Okay, and then if you have the 3Rn minus 1, so this is the delayed version, starting at n equal to 1. Okay, each increment is 3, so 0, 3, 6, 9, 12 up to infinity. You understand now? You need to know these three basic discrete signal because you need to find the numeral sequence in the later section. So numeral sequence is a discrete signal can be obtained from a summation or combination of impulse, ramp, and step function. That's why in the later section, you need to find the numeral sequence. It's a combination of three basic signal. Okay, now let's look at the example. Given yn is this one, okay, find the yn in numeral sequence. So if you look at this yn, you have the unit step function, you have the ramp function, here also a ramp function, unit step and ramp. You need to add up everything, sum up everything, and then to find a yn. Okay, if you don't know how to write the function here, you don't know where to start, so it's impossible to find the numeric sequence. Okay, now let's start with this one. Draw a table first. First of all, check the question. Look at which function is the leftmost and which function is the rightmost. Okay, which signal? This one is n plus 2, so means that n equal to -2. Okay, and then this one n minus 5 means that n equal to 5. So starting from n equal to -2 up to n equal to 5. So in your table, you write down the n here from -2 to 5. And then you need to do the extra 3 columns, because later we will need you to use for the ramp function or ramp signal. Okay, first of all, let's look at this one. The first signal is -3 u m plus 2. Okay, you write it here, -3 u m plus 2. Okay, as I told you just now, n plus 2 means that the n is starting from -2 up to infinity. And the amplitude is -3. So you may write down your signal here, -3 starting from -2 up to infinity. So all the value are the same because this is a unit step. And next signal is the Rn plus 2. Okay, as I told you just now, Rn plus 2, each increment is 1 and starting from -2. Okay, you have start from 0. The ramp must start from 0. So 0, 1, 2, 3, 4, 5, 6 up to 10. And then next signal is 2 Rm plus 1. Okay, each increment is 2 for the ramp and starting from n equal to -1. So at n equal to -1 here, you start with 0. Each increment is 2. So 2, 0, 2, 4, 6, 8, 10, 12 up to 18. Okay, next signal is -3 Rn. Okay, -3 Rn. So each increment is the -3. Okay, it's a ramp signal starting at n equals 0. So when n equal to 0, you have to start with 0 and then -3, -6, -9, -12 up to number n equal to 8. And then the next signal is un minus 1. U is a unit step function, amplitude is 1 and starting from n equal to 1 also. So starting from n equal to 1 here, and then the amplitude all are the 1. Okay. And then next signal is a negative 3, u, n minus 3. So the amplitude is negative 3. And then starting from n equal to 3. Okay, starting from n equal to 3, the amplitudes all are 3s. Next signal is the Rn minus 4. So it's a ramp signal. Starting from n equal to 4, each increment is 1. Okay, so n equal to 4, each increment is 1. So you must always remember it start from 0. Ramp signal always start from 0. So 0, 1, 2, 3, 4. Okay, class, if you look at here, the original signal is start n at 5. That's why I asked you to do the extra 3 column here so that you can write down another 3 value. Okay, the last signal is negative Rn minus 5. Okay, it's a ramp function again, and n start with n equal to 5. Okay, so each increment is negative 1. So 0, negative 1, negative 2, negative 3. Okay, in order to find the numeric sequence, you need to sum up all the signal here because yn is equal to this one plus this one plus this one plus this one or minus this one. Okay, you need to sum up everything. So I sum up everything here. So negative 3 plus 0, you get negative 3. Negative 3 plus 1, you get negative 2. Negative 3 plus 2, so plus 2 again, so negative 3 plus 4, so you get 1. And then negative 3 plus 3, you cancel out. So 4 minus 3 plus 1, so you get 2. And then here, negative 3 plus 10 minus 6 plus 1, so you get 2. And then negative 3 plus with 13, you get positive 10. And then minus 9. Okay, and then plus 1 minus 3, then you get negative 1. And then the column number 4, negative 3 plus 16 minus 12 plus 1 minus 3. Then you get negative 1. And then the fifth column, you get negative 3 plus 19 minus 15 plus 1 minus 3 plus 1. Then you get 0. Okay, column number 6, same again. Negative 3 plus 22 minus 18 plus 1 minus 3. Okay, plus 2 minus 1, you get 0. All same to the column 7 and column 8, you get 0. Okay, class. If you have value for the extra 3 columns behind, if you have the value of 0, this means that you will get the correct answer. Let's say if you have some value at the extra columns, the extra 3 columns here, you still have some value. This means that the operation here, okay, the signal, maybe you got it wrongly. So please check back your answer, all right? So you sum up these things, then you get this is the numeric sequence. So negative 3, negative 2, 1, 2, 2, negative 1, negative 1. You can write down until the number 5 here. Okay, but since this is 0, so it don't contribute anything, you just write up to negative 1. And then where is the origin? Origin, you can refer to n equal to 0. Okay, the value is 1. So you have the marker here at origin when n equal to 1. And when n equal to 0, the value is 1. So this is how you get your numeric sequence. Do you understand now? Next, I would like to explain more on the property of the discrete impulse. The product of xn with the impulse delta n minus k will result in the xn delta n minus k equal to the xk delta n minus k. Okay, what does this mean? this means that the xk, the summation of the xk, xn and xn delta n minus k is equal to xk, where the k here is referred to the location. Okay, and the overall xk, the everything of xk is the magnitude, or we call it amplitude of the particular location. Now let's look at the example here. If the numeric sequence xn is 3 to 1 to 1, where the origin is at 1, where the origin is at the value of 1, okay, and then if you plot this numeric sequence, okay, if you don't know how to plot, if you plot the numeric sequence, at origin the value is 1, at -1 you have a value of 2, and at negative value at n equal to 2, -2, you have the value of 3. And then at the right hand side, at n equal to 1, the value is 2. At n equal to 2, the value is 1. Okay, this is the numeric sequence, and here we plot the numeric sequence. And then if you look at here, the xn multiply with or product with delta n minus k. Okay, for example, delta n minus k here is delta n minus 1. Okay, delta n minus 1 means that the value, the amplitude is 1 at the location at 1. Okay, here, location 1, amplitude is 1. You product these two, what will be the result? Is the xk, right? So you product these two, okay, means that 3, okay, at the location at -2 or n equal to -2, 3 times 0, you get 0 here. And then 2 times 0, you get 0. And then at origin, 1 times 0, you get 0. And then 2 times 1, you get 2. And then 1 times 0, you get 0. Okay, so this xk, the value is 2 delta n minus 1, because the amplitude is 2 at the location n minus 1, delta n minus 1. Okay, you understand now? Now, to represent the xn or the discrete signal, there are two ways. First is a numeric sequence, as I told you just now. Let's look at this one in the numeric sequence. And the second one is the summation of signal, either the impulse, step, ramps, or combination of step and ramps. For example, given the numeric sequence xn is 1, 4, 3, 2, 1. Okay, if you want to write in the xk form, we write it at x -2. Because if you look at here, we know that this is origin, this is -1, this is -2. So x -2, the location here is, still remember the location here, x -2, the value is 1. Okay. At n equal to -1, the value is 4 here, where the value of 3 is at the origin. Origin is x0. So origin always 0, remember this one. And then next is the n equal to 1, the location. N equal to 1, you have the value of 2. And at n equal to 2, you have the value of 1. Okay, if you want to write in a delta form, it's like this. If you have n negative n x -2, the location, you can write in a delta form is n plus 2. Okay, so here I write in the delta form, delta n plus 2 is this one. Okay, this means that at location n equal to -2, you have the value of 1 here. And then at location n equal to -1, you have the value of 4. This one is if you draw it, okay? If you draw it and write it in the form of delta. Okay, this is all is draw it. Delta n -2 at the location n equal to 2, the amplitude is 1. Okay. So the summation of the signal will result in x negative 2. This is location. X negative 2, negative 2 is a location. Delta n negative 2, this one also refer to a location. Okay. And then plus with x negative 1, delta n plus 1. And then x0, okay, and delta n plus with x1, the location is 1, multiply with delta n minus 1. So n also equal to 1. For this one, x2, x at location number 2, multiply with delta n also equal to 2. So you multiply. This one is the summation of signal just for the location form, but not in the value form. We look at another example. Okay, using the previous example that just now, write down the sum of the shifted impulse, sum of the step, and sum of the ramp. So the first step is to find the numeric sequence. So this is very important. For the previous example, the yn is negative 2, negative 3, negative 2, 1, 2, 2, negative 1, negative 1. And then next is the sum of the shifted impulse. Okay, this is after you find the numeric sequence, you need to find the sum of the shifted impulse if the question asks you to do so. Okay, shifted impulse, this means that the summation of the xk delta n minus k. So just like the previous example I showed you just now. So the x3, this one, if you refer to this one, the amplitude is negative 3 at n equal to negative 2, right? At n equal to negative 2. So you write as negative 3 delta n plus 2. And then for this value, negative 2, so negative 2 delta at the location n equal to minus 1. So n plus 1. And then next one is at the origin. So you only have the amplitude is 1, so you have delta n. And then next one is to plus 2. The amplitude is 2. The location is n equal to 1. So the delta is n minus 1. And then the next one is amplitude is 2 again. And then the location is at 2. So 2 delta n minus 2. And then minus with 1. Okay. Amplitude is at 3. So n minus 3. And then minus 1 again, the amplitude. Location is 4. Okay, 1, 2, 3, 4. So amplitude is n minus 4. So this is called the sum of the shifted impulse. So this is quite simple. And then next question is sum of the step. Okay, second question is the sum of step. So for sum of step, there are a few procedures or guideline to help you to solve this question. So the first one is to draw a table and determine the sample limit. Okay, draw a table, get this table, and then determine the sample limit. As you notice here, the n starting from negative 2 up to positive 4, right? Up to positive 4. So you need to add the extra columns. Okay, so up to 4, so you add up 5, 6, 7. 3 column extra would be enough. So you take the extra columns. And then the third one is to write down the numeric sequence. Write down the numeric sequence. So what is your numeric sequence? Negative 3 delta n plus 2. Okay, negative 3 delta n plus 2. Oh, sorry. This is the question 1. We should refer to the sum of the step. Okay, what's mean by sum of the step means that all the result must come from the sum of step, the summation of step. So all the result must from the step, you see, must from the step. So the value is negative 3. What we need is the negative 3, right? So negative 3 unit step m plus 2. So as I told you just now, m plus 2 means that it's starting from negative 2 to infinity. The value is remain to negative 3. Okay, all negative 3 here. You fill in all negative 3. Okay, can you follow here? Now, next value is negative 2. Okay. So your numerous, okay, if you check the question is negative 3, negative 2, 1, 2, 2, negative 1, negative 1. So you write down your numerous sequence is negative 2, negative 3, negative 2, 1, 2, 2, negative 1, negative 1. You write down this one first because this is your target. This is your target. In order to make it like 0, to make it have the same value, this one, what should you have? You need to have negative 3, right? How to achieve negative 3? How do you achieve negative 3? So you need a negative 3. So negative 3 or negative 3. Okay? So the first one is a negative 3. Then what is next? Okay? If you want negative 2 and now you have negative 3, you need to plus 1. So negative 3 plus 1, then only you can achieve negative 2. So you need to top up 1. Okay, so negative 3 plus 1, you will get negative 2. So what is the unit step? So amplitude is 1, starting from n equal to 1, so n plus 1. It's a unit step function, 1, 1, 1, 1, 1, 1, up to here. And then, how to achieve 1? Now you have negative 3 plus 1. Okay, negative 3 plus 1. How to achieve 1? Okay, negative 3 plus 1 is negative 2. Negative 2, how to obtain 1? So you need to plus another 3. Okay, you plus another 3 in order to obtain 1. So you need to plus negative 3. You need to plus with 3. 3, 3, 3, 3. Can you follow now? If you really don't know what the process or what is the value that you need to add, actually it's as simple as like this. For example, for the previous example is negative 3 plus with what in order to get negative 2. So you can write a simple equation like negative 3 plus with 8, x equal to negative 2. So x equal to negative 2 plus 3 equal to 1. So this one here means that you need to top up with 1. That's why you have the 1 here. Okay? So similarly to get the value here. For example, now you have negative 3 and 1. So negative 3 plus with 1 plus with x equal to 1. 1 is here, I refer to this. So equal to negative 3 plus 1 plus x equal to 1. So x equal to 1 plus 2, okay, equal to 3. Equal to 3 here. So similar to others. So how to get negative 2 and how to get positive 2? So negative 3 plus 1, you get negative 2. Negative 2 plus 3, you get 1. Okay, then from 1, how to get 2? So you plus 2. So at plus 1, you get 2. So the value here is 1. And then next one, how to get 2? If you have the value of negative 3 plus 1 plus 3, Okay, negative 3 plus 1. So this one is a remand. So it's same value, so we don't do anything. What about this one? How to get negative 1 if you already have the value like this? So negative 3 plus with 1 plus with 3 and then plus with 1 again, you get negative 4. Okay, if you already have negative 4, then how to get negative? So negative 3 plus 1 plus 3 and then plus 1. So all this is equivalent to 2. Okay, 2, how to obtain negative 1? You need to minus 3. So you get negative 1. That's why you top up the negative 3 here. Okay, so this one also the same. And then the last part is you sum up everything and you get 0, 0, 0. So this 0, 0, 0 is to show that it's a correct answer. Okay, you sum up everything. This one also sum up. If you sum up, then you check whether your sum up value is the same as the numeric sequence. If it is the same, this means that the sum of the steps here are correct. Otherwise, you need to check your answer. So when you write again the sum of the step, you need to write down your answer. Yn equal to negative 3 unit step m plus 2 plus unit step m plus 1 plus 3 unit un and then plus with un minus 1 and then plus with negative 3 un minus 3 plus un minus 5. So this is we call sum of the step. Next question is sum of RAM. Okay, sum of RAM. For sum of RAM, this means that you need to extra one sample in front. So just now you know that for the sum of the step, the sample is from negative 2 to 7, right? So now it add one more step is from negative 3 to 8. Okay. So again, you write down the numeric sequence. Negative 3, negative 2, 1, 2, 2, negative 1, negative 1. Okay, you follow. You follow the location, okay? The origin is at, the value is 1 at the origin. Okay, so first of all, how to achieve negative 3 if you want to have RAM signal? So of course, the RAM signal, if you're negative 3, then the signal should be negative 3 Rm plus 3 because the location is at 3. So it's n plus, the location is n equal to minus 3. So n plus 3. The RAM is starting from 0, negative 3, negative 6, negative 9, negative 12, up to the sample limit. And then next one. Okay, this one is negative 3 and then negative 6. Okay, how to get negative 2 if you have the value of negative 6? Okay, negative 6 plus 4, you will get negative 2, right? So you need to plus with 4. Okay, for the RAM. So this means that for the starting for the RAM, the amplitude is increased. Each one increase 4. So the amplitude should be 4. 4 is a positive, right? So 4 Rm plus 2. Okay, because you must start with location n equal to minus 2. So n plus 2. So each increment is 4. So 0, 4, 8, 12, 16, blah, 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 up to sample limit. And then next. Okay, now next one is, this one is negative 9 and 8. So negative 9 plus with 8, what do you get? Get negative 1. Okay, negative 1, what value you need to add in order to get 2? Okay, negative 1 plus with, what value you need to get in order to get 1? So you have negative 1 plus with 2, you get positive 1, right? So negative 9 plus with 8 plus with 2, okay, you will get the 1, value of 1. Okay, again for the RAM, this is the amplitude of 2, starting from minus 1. So R and 2R n plus 1. Now you get this one. So 0, 2, 4, 6, 8, blah, 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 up to sample limit. Next, now you have negative 12 plus with 12 plus with 4. So you get 4. Okay, if you already have 4, how to get 2? It's minus 2. That's why your top here is minus 2. So minus 2. This is a RAM. So starting from this one, n equal to 0. So each one increment negative 2. So negative 2 are n. So you get 0, negative 2, negative 4, negative 6 up to sample limit. Okay, next one. Now you have negative 15 plus 16 plus 6, negative 4. You get 3. Okay, you have the value of 3. Now how to get 2? You need to minus 1. Okay, you minus 1. So each one increment is minus 1. So minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. And then we write as negative R n minus 1. Okay. Well, next value is negative 18 plus with 20 plus with 8. Then plus negative 6. You get 4. So you have 4 now. How to get negative 1? So you need to minus. So you minus 3. So you minus 3. So 0, negative 3, negative 6, negative 9, negative 12 until sample limit. So it is the same for the others, like this one. So you have negative 1 plus 24 plus 10 plus and minus 8 minus 3 minus 6. So in order to you need to plus with 3 only you get minus 1. So you top up with 3, 6, 9, 12, 15 for 3R and minus 3. The same to the others. And then you sum up. Again, you sum up everything. Make sure this numeric sequence is the same as this one. If it is the same, means that the answer is correct. Okay, in order to further check whether your answer is correct or not, make sure the the value after the the sample limit, okay, is the 0 value. Okay, now you can write down the sum of the RAM signal. So you add up everything, you sum up everything, so you write down in this RAM form. Okay, if the question asks you sum of the RAM, this means that you only can use the RAM signal to form the sum of the RAM. You cannot say sum of the RAM, the signal for sum of the RAM, you add up, okay, I can increase RAM or I can increase together with the unit step or the impulse. Cannot. Unless the question said sum of the RAM and unit step, then your answer can be combined unit step and RAM. Otherwise, it's not allowed. Next, I would like to share on the discrete pulse signal for the rectangular and triangular signal. What is the difference if you have the different value or different amplitude, and how's the rectangular and triangular signal looks like? Okay, discrete pulse signal can be divided into two. One is the rectangular we write in the form of rect n over 2n. So the signal is in the rectangular. Whereas in triangular, that one is n over capital N. The signal is in the triangle form. Okay, what is the difference between rectangular and triangular? Both have the n and have the capital N. Okay, now let's look at the rectangular. Rect n over 10. This means that rect n over 2 times 5 is equal to 10, right? So this n, 2 times 2n, right? 2n here, the n, if I separate it into this form or I reformat into this form, rearrange into this form, I will get 2 times 5 is equal to 10. So this 5 is represent the capital N. Okay, what is the impact of this in terms of the figure? Okay, this means that this 5 here is from negative 5 to positive 5. If you write it or if you draw it in a graph, it's starting from negative 5 to 5. And then if you write in a numeric sequence, you will have the 1, 1, 1, 1, 1, 1, because the rectangular amplitude is 1. And then from negative 5 to 5. Okay, so you have negative 1, 2, 3, negative 4, negative 5. Positive 1, positive 2, positive 3, positive 4, positive 5. So this is rectangular n over 10. Okay, what if I have the amplitude of 2 and n over 4? So if you rewrite in this form, means that the n equal to 2 times 2. So the n is from negative 2 to 2, amplitude is 2. Okay. What if I have n minus 1 over 4? This one is a combination of a delay, like a fraction delay. But this one can be also, if you want to write in the form of rectangular, is a delay format. So n 2 times 2 is from negative 2 to 2. Okay, this one is a numeric sequence. So n minus 1 actually is a delay. So you move the marker to the left 1 unit. Okay, you move the marker 1 unit to the left. So the graph will be like this, from negative 1 to 3, because you already shifted. Okay, the marker, you change the marker, and then the origin is here. New origin is here. Okay, what if you have the two rectangular m plus 2 over 6? This one is at once. Okay, you move the marker to the right, 2 unit. Okay, before that, you need to plot the two rectangular n over 2 times 3. 2 times 3 is from negative 3 to 3. The amplitude is 2. Okay, and then next is to move the marker 2 unit to the right. So this is your new origin. Okay, see here. So after you learn about the rectangular, now go to the triangular. Okay, n over capital N. Okay, if you have try n over 3, this 3 is from negative 3 to 3. Negative 3 to 3. So it's a triangle shape. But starting from 0. Starting from 0. So 0, 1, 2, 3. Okay, 0. And then up to maximum is here. Okay, you have the negative 3 and 3. But must start with negative 3 until 3. End at 3. Okay. Then what is the value? You need to know the value. Okay, how to get the value is, for example, how to get the first one? How to get the value of first one? If you know that this one is 0 and this one is 1. What is the value of 1 and 2? Okay, you can do it like this. 0 plus with 1 minus 0 divide by 3 because 1, 2, 3, right? So divide by 3 time with the first one. You are the first one, so you are the first one time 3 time 1. So you get 1 over 3. The second, 0 plus with 1 minus 0 divide by 3 time with 2 because you are the second time with 2, you get 2 over 3. And then the third one, you already know that is 3. So this is the formula. Okay, this is the formula that I already written here. And then you can write in the form of numeric sequence. So 0, 1 plus 1 over 3, 2 over 3, and then 1. 2 over 3, 1 over 3, 0 again. So this is a numeric sequence for triangular. Then what is the signal will looks like if you have 2 triangular n over 2? Okay, from negative 2 to 2. If you have 2, so negative 2 to 2. Okay, the amplitude is 2. Just now amplitude is 1, right? 1 try, so amplitude is 1. Now the amplitude is 2 because of the 2 try here, the amplitude 2. So in the graph, if you sketch, you can sketch like 0, starting from 0, and then maximum is 2. Starting from negative 2, maximum is, the amplitude is 2. So what is the value here? Okay, you can use the formula 0 plus 2 minus 0 over 2 because 1, 2, we time with the 1 because it's considered as the first one here. So it's 1. Again, what is the signal looks like if you have 2 triangle, 2 try n minus 1 divided by 2. So again, first of all, you need to change to n over 2 first. You need to draw this one first. Okay, 2 try n over 2, you get 0, 1, 2, 1, 0, origin at value of 2. So n minus 1 means that it's a delay version. You shift the signal 1 unit to the left. Okay, you shift the origin 1 unit to the left, you get this one. Okay, next is 2 triangular n plus 2 over 2. So it means that you shift the origin 2 unit to the right. So initially is here, you shift 2 unit to the right is 1, 2. So you get the new numeric sequence here. Okay, class, do you understand now? Okay, hope you enjoy the video, and if you like my video, you can like the YouTube video. And thank you for watching, and I hope you enjoy. Thank you.